In this video, we're going to explain how ambiguous triangles work. So this is how every question is set up. Triangle ABC has one angle, one side, and another side, and that second side is always opposite the angle that we have. So you can see it's angle A and side A, and it says solve the triangle. The key to these questions is first drawing them properly, and we're always going to draw them with a horizontal line and the angle here in this bottom left. So 35 degrees looks maybe something like that. Try and draw it accurately just so you can get a good picture. So I'm going to call this A because that's the angle we're given. I'm always going to make that in the bottom left. Now, I've also got a side that's opposite this angle, so I know that's going to be over to the right. And I'm going to make my other side this one right here. So that's 11 centimeters. So that'll be B, which means this will be angle B over here, and this will be angle C over here. Now, that's 11 centimeters. The key that gives away this might be an ambiguous is that the opposite side is shorter than 11. So I'm going to show you two ways that this triangle can be drawn. I'll keep the first one in black. So if 11's there, 7 can be something like this. You can see it's clearly shorter than the 11, and that sort of satisfies all the criteria. Now, the other way that could be drawn is, again, the 11 can't change and the 35 degrees can't change. But the 7 centimeters, that side could actually swing underneath here and create this triangle. Right? We're still within all the criteria given in the question. But because that 7 centimeters is shorter, it could actually be under there, creating an obtuse angle here as opposed to an acute angle here. So hopefully you can see the two triangles, the black one and the blue one, and I know it's just hand drawn, but that gives you a good clue that this might be an ambiguous case. So how do we figure out the actual values for this? Well, clearly we have a angle A and side A. Whenever we have a non-right angle triangle and an angle with its opposite side, we can use the sine law. So I'm going to try and find angle B. So sine B over 11 equals sine 35 over 7 centimeters. Okay, so this is going to find angle B. Now you're probably seeing, well, this is angle B, but this could also be angle B, and you're exactly right. Let's see how that works. If we toss this into the calculator, we'll get sine B equals sine 35 degrees times 11, I just cross multiplied, over 7, and so we'll get B equals 64.33 degrees. We do that by taking the inverse sine of this right side, inverse sine. Okay, so under this scenario, let's do sort of triangle 1. I'll say this is the black triangle, and this is the blue. Now we're going to see if this works, so that there are two possible answers. So we know angle, and we only have to worry about the angles. Angle B we just found to be 64.33 degrees. We know angle A has to be 35 degrees. And since we know 180 degrees in a triangle, this would leave angle C to be 81 degrees, roughly. I'm just doing 180 minus. Okay, great. So that's one option. Now, in our blue triangle, we know angle A still has to be 35. We can't change that because that was given in the question. But angle B could also be this one. Instead of the acute angle of 64.33, how do we find this angle, this possible answer? Well, it's just 180 minus. 180 minus 64.33. So angle B equals 115.67 degrees. And that should make sense because we know the rules for sine. Sine of theta is the same as sine of 180 minus theta. So it doesn't matter, right, that when we do that inverse sine in the calculator, it's always going to kick out the acute angle, but the answer is also valid if we do 180 minus. And you can see that because these two angles here share a line. Now, that could be the other answer for B. Let's see if it's actually possible. And the way we know if it's actually possible is if there's still room in the triangle for angle C. So in other words, do these two add up to 180, angle A and B? And no, they don't. They add up to 150, 150.67, leaving about 29.33 for C. So, in conclusion, you use the sine law to find your first triangle with an acute angle for B. You do 180 minus B to find the second potential for angle B. And then you add that to angle A, which is given in the question. If you're still less than 180, then angle C has a second potential answer. So angle A plus angle B, if that's less than 180, you've got an ambiguous case where there are two answers.